Okay, get this. What if I told you that you, right now, just sitting there, are traveling at the speed of light? I know it sounds completely impossible, right? But just stick with me here because we're about to dive into an idea so wild, it's going to completely flip how you think about motion, time, and, well, the entire fabric of reality itself.
We all know the rule. It's like Physics 101. Nothing with mass can reach the speed of light. And you've probably heard the usual reasons. That it would take infinite energy or its mass would become infinite. But let's be honest, those answers don't really feel satisfying, do they? They sound more like mathematical side effects than a deep fundamental reason why. Today, we're going for that deeper reason.
And this is the key to the whole thing. This amazing paradoxical quote just turns the whole question on its head. It suggests that the cosmic speed limit isn't some barrier we're struggling to break through. No, it's a constant speed we can never ever escape. So let's unpack what on earth that actually means. So first up, let's just look at this rule itself, the cosmic speed limit. This isn't just a friendly suggestion, it's a hard-coded law of the universe. But where does a law like that even come from? This little constant c shows up absolutely everywhere in physics. And it's so much more than just how fast light travels. You can think of it as the speed of causality itself, the speed at which information can move through the universe. The very fact that this speed limit exists is one of the biggest clues we have about how our universe is actually built. And to really get it, we need a totally new way of looking at things. To wrap our heads around this, we're going to use a really powerful analogy. What if the world we experience, our 3 dimensions of space and 1 dimension of time, are really just projections, like shadows, cast from some kind of higher dimensional reality we can't directly see? Okay, picture this. A world of beings who live on a perfectly flat, 2-dimensional surface. Their entire reality is just forward and back, left and right. The very concept of up or down would be totally meaningless to them. All they can ever see are the shadows of things that pass through their flat world. Now, imagine an airplane flying over their 2D world at a perfectly constant speed. From the shadow people's point of view, things look really weird. If the plane flies straight up, away from their world, its shadow on the ground doesn't move at all. They'd say its speed is 0. But if the plane starts flying diagonally, its shadow starts zipping across the ground. And if the plane flies perfectly level, parallel to their world, its shadow moves at the fastest possible speed it can. So get this. Even though the real plane is always moving at one constant speed, our shadow people would measure a speed that changes and has a definite maximum limit. This is where Einstein's old professor, a guy named Hermann Minkowski, had an incredible flash of insight. He suggested that our reality works exactly like that. What we perceive as space and what we perceive as time aren't separate fundamental things. They're just like those shadows. They're projections of a single, unified, 4-dimensional reality that he called space-time. So how could the shadow people ever figure this out? They'd have to look for something that doesn't change, something that's invariant. A really clever shadow mathematician might notice that even though the shadow's horizontal speed keeps changing, if they could somehow measure the up-down component, they discover that the sum of their squares is always the same constant number. That constant value would be their big clue, their proof that what they're seeing is just a projection of a real object moving at a constant speed in a higher dimension. Okay, so now let's take this incredible idea and bring it back home into our reality. Let's talk about traveling through space-time, because we can apply this very same logic to ourselves. We're not 2D shadow people, we're 4D space-time beings. So just like that airplane shadow had a horizontal part and a vertical part, our own motion has 2 components. What we think of as our speed, moving through the 3 dimensions of space, is just one piece of the puzzle. The other piece, the one we don't normally think about, is our speed through the dimension of time. And this is it. This is the master rule of the universe. Every single thing, from the tiniest particle to a galaxy to you sitting there right now, is constantly, always, and unchangeably moving through 4-dimensional space-time at one and only one speed, the speed of light, c. And there it is. That's our invariant. Just like the shadow people could use the Pythagorean theorem to figure out the airplane's true constant speed, we can do the exact same thing. The square of your speed through space plus the square of your speed through time will always equal the speed of light squared. No exceptions. It's true for everything in the universe. And what's so incredible is that this one simple, elegant idea, this one master rule, unlocks all the mind-bending weirdness of special relativity and makes it all feel, well, almost perfectly intuitive. Think of your total speed like a fixed budget.
You have a total velocity of c that you have to spend between moving through space and moving through time. Right now, as you're sitting pretty much still, you're spending almost your entire velocity budget just moving through time. You're aging, you're traveling into the future at the fastest possible rate. Your personal clock is ticking as fast as it can.
And suddenly, everything just clicks into place. Time dilation? Oh, that's easy. When you start moving really fast through space, you have to borrow some of that velocity from the time dimension. You're literally trading speed through time for speed through space. Length contraction? That's just what an object looks like when it's tilted in 4D spacetime. Its shadow, its projection in our 3D space just appears shorter. And that ultimate cosmic speed limit? You can't reach the speed of light in space because, to do it, you'd have to use your entire velocity budget for space, leaving nothing left for time. You would literally have to stop moving through time altogether.
So let's just get that old idea of the speed of light being a barrier out of our heads. It's not a finish line we're racing toward. It's the constant, unchanging speed that's on the odometer for everything in the universe all the time. The only choice we have is how we split that speed between moving through space and moving through time.
This whole way of thinking is just mind-bending. It means our most fundamental experiences, space, time, motion, are just slices of a much bigger, more unified reality. And it really makes you wonder, doesn't it? If our familiar world is just a projection, just a shadow of something deeper, what other incredible truths about the universe are we not even seeing yet?